built on your knowledge of finding the prime factorization of numbers, and you will also be using those skills to find the greatest common factor of monomials. This will be a quick video and a quick lessons. The prime factorization of a number is that number broken apart into its smallest pieces. You can do this by making a factor tree. For example, 98 is equal to 2 times 49. 49 is equal to 7 times 7. Therefore, the prime factorization of 98 is equal to 2 times 7 times 7. There is only one specific prime factorization for every number. There's only one number, only one way to break a number apart into its prime factors. Now remember, you can write this in exponential form as 2 times 7 to the second power. If you remember, the greatest common factor of two numbers is the largest factor that goes into both of them. Let's look at the numbers 100 and 60. The prime factorization for 100 is equal to 10 times 10, or broken apart further, 2 times 2 times 5 times 5. I did not make a factor tree. I just kept breaking the number apart in my head until I had all prime factors. The prime factorization of 60 is equal to 10 times 6, or writing this in order from least to greatest, 2 times 2 times 3 times 5. I know this is correct because when I multiply it together, I get 60. 2 times 2 is 4, 4 times 3 is 12, 12 times 5 is 60. I can find the prime factorization in a visual way by drawing a rectangle around my pairs of factors that I have in common. I see that I have the following factors in common: a 2, another 2, and a 5. Therefore, the GCF of 60 and 100 is 2 times 2 times 5, or 20. You can find the greatest common factor of monomials in a similar way. Let's look at the monomials: 3x cubed and 6x squared. We're going to break these apart into their smallest prime factors. 3x squared becomes 3 times x times x. 6x squared becomes 2 times 3 times x times x. And you probably spotted my mistake. 3x cubed is 3 times x times x times x. It's always good to look back. Now I'll put a rectangle around my common factors. I have a common factor of 3, a common factor of x, and another common factor of x. Therefore, the GCF of my monomials, 3x cubed and 6x squared, equals 3 times x, or 3x squared. One more example of that type. 8x squared and 7y cubed. The prime factorization of 8x squared is 2 times 2 times 2 times x times x. The prime factorization of 7y cubed is 7 times y times y times y. As you see, there are no factors in common. There are no numbers in common. There are no variables in common. Therefore, the GCF of 8x squared and 7y cubed is 1. We're almost finished for today, but I do have a word problem for you. Here it is. A cafeteria has 18 chocolate milk cartons and 24 regular milk cartons. The cook wants to arrange the cartons with the same number of cartons in each row. We have 18 chocolate, 24 regular. Chocolate and regular milk will not be put in the same row. How many rows will there be if the cook puts the greatest possible number of cartons in each row? So hopefully you're looking at this and realizing we need to find the greatest common factor of 18 and 24. Well, the greatest common factor of 18 and 24 is 18 is 2 times 3 times 3. 24 is 2 times 2 times 2 times 3. So the greatest common factor is 2 times 3, which is 6. Now 6 is not my answer, however. Let's think again about the problem. I have 18 chocolate milk cartons and 24 regular milk cartons. What does the number 6 represent? The 6 represents the 6 cartons in each row. To determine how many rows, I need to see how many rows of chocolate I'll have and how many rows of regular I'll have. I have 18 chocolate milk cartons. There will be 6 in each row, so I will divide by 6. That means there will be 3 rows of chocolate. Similarly, I have 24 regular milk cartons. I'm going to put 6 in each row, so I'm dividing by 6. That tells me there are going to be 4 rows of regular milk with 6 in each row. Well, if there's 3 rows of chocolate and 4 rows of regular, that tells me that there will be 7 rows altogether. So there's 3 rows of chocolate, 4 rows of regular, that's 7 rows altogether. The 6, the greatest common factor 6, remember, was the number of milk cartons in each row. That's all for today. As I said, it was a short lesson, and you'll have a short assignment tomorrow. Thank you.